energy. Okay, so we've already discussed which the different types of energy. Okay, and yung mga other parts sa ating mechanics na lesson. And so we will now focus on this module, okay, the conservation of energy. How does the energy transfers, or is it created? Can it be destroyed? Okay, so without further ado, let's start. Okay, so we will start with our intro. Okay, we will introduce muna this topic, syempre. Okay, so we have a supplemental, and paalala lang, we have a supplemental module para dito. Okay, so na pwede nyong tingnan or i-reference nyo as you are learning. Okay, so we will start with the introduction. So we have preliminary activities. First, I will reveal the learning outcomes. Okay, and then the overview, and also our preliminary activity proper is the virtual lab, which I expect you to answer. Okay, and also I will give an overview, okay, ng mga gagawin, or mga overview na knowledge para meron kayong maisagot. Okay, and to help you analyze, okay, and discover for yourselves. Okay, so preliminary activities. So we will start with our learning outcomes. Okay, these are the targets. Okay, so actually we have 3. Okay, so after going through this module, okay, you will be able to do the following. Okay, so these are the 3 learning outcomes of our lesson. Okay, first one is explain energy transformation in some activities or events like skate parks and amusement rides using the PhET simulation. Okay, then next, another one is, okay, to perform activities to demonstrate conservation of mechanical energy. Of course, I will have you perform different activities so that you can demonstrate or see for yourself or experience in first hand, okay, the conservation of energy. Okay, and as for the first objective, okay, for our first objective, we will only use virtual simulation. Okay, so that to give context, okay, or concepts, okay, preliminary knowledge. Okay, and also the last but not the least, we have inferred that the total energy remains the same during any processes. Okay, so that you will at the end of this module, okay, you can say surely for yourself, okay, that the total energy on all process or any processes will always be the same no matter what happens, or okay, the total energy na. Okay, okay, next, let's move to the overview. Okay, these are the overview ng ating lecture video, okay, and also the overview of our modules. Okay, so first we have intro part. So alam natin ito yung kanina. Okay, natapos na natin yung overview. Oh, sorry, dapat pala overview muna. Okay, but by the way, it's always we're always adaptable naman. Okay, so overview, we are doing it right now. And then the learning outcomes, na-excite ako, nasabi ko na sa inyo agad. Okay, and then number 3 is the let's explore, which is the virtual laboratory. Okay, then next we will have a lecture part. Okay, as you can see sa ating first part ng sa pinaka main dashboard natin sa Prezi. Okay, so we have the lecture. Okay, hinati ko to sa tatlo. Ito ay yung discussion, examples. Okay, after the discussion, syempre we will have different examples so that you can know, okay, and you can apply it sa inyong pang araw-araw na buhay. Okay, and mas lalo nyo pang maintindihan at ma-process or ma-exercise ang inyong problem solving skills and calculation. Okay, next, lastly, we have let's wrap up. Okay, these are just the generalization of our whole discussion. Okay, The next one, okay, and the last one, we will have let's check. Okay, this is the assessment. Okay, so first let's assess. Okay, in this part I will just explain to you kung paano nyo sasagutan yung ano, yung dito, yung mga topic or yung mga mga assessment. Okay? So that's that. Okay? And also yung full assessment makikita nyo dun sa inyong module. Okay? So next we have the answer key. Okay? So yung answer key na yan, okay, I will give the answer key to some of the examples. Okay? As well as siguro yung mga rubrics, nandiyan na yun lahat. Okay? And then the third one is the references. Okay? So syempre, hindi ko naman to ginawa lang ng sarili ko, hindi ko to inanap sa sarili ko, 'di ba? I will always give you references so that you can have other information or knowledge kung mas gusto ko pang mag-delve deep sa sa lesson na ito. Okay, if you want to read more articles, journals, or books, okay, to further your knowledge, okay, you can find it in the references. Okay? Okay, kung masyadong mabilis kung na-present sa inyo, you can just rewind the video for you to understand. Okay, more. Okay, let's move on with the virtual lab. Okay, so the virtual lab. Okay, so the virtual lab or virtual laboratory, this is our explore part. Let's explore. Okay, so the virtual laboratory, we have three situations. Okay, so A, B, C, and C. Okay, we can also see that sa inyong module. Okay, in situation 1, we have a man skating down, okay, in a frictionless ramp. Okay, so take note that the ramp na ito ay frictionless. Okay, a man is skating down. Okay, skate down siya. Okay, next we have the situation 2, a man is skating up the frictionless ramp. Okay, so as you can see there, situation 1, pataas. Situation 2 is pababa. Okay, and in situation 3 naman, a man is skating back and forth on a rough ramp. Okay, so this one, okay, it is skating up and down or down and up, okay, but in a rough ramp. Ibig sabihin, the friction is present. Okay, so yan ang ating mga pag-uusapan. Okay, and as I explain, while I'm explaining, I want you to answer your virtual laboratory part sa ating, or let's explore part sa ating sa ating module or sa inyong module dyan. Okay? Okay, so let's see. Let's go with situations 1 and 2. Okay? So this one, ipag-iisahin ko na lang. I will show the GIF or yung animation. Okay? The loop animation. Okay? In which pababa siya, pababa and pataas, not simultaneously, alternately. Okay? So this one, as you can see here, okay, so yan. Okay, so wait lang ha. Okay, so let's start with this one. Okay, pababa siya and then pataas. Okay, so what do you think ay nangyayari? Okay, so okay, so let's start there. Okay, sige. Habang pababa siya, anong napansin nyo? Okay, so habang pababa siya, parang bumibilis siya ng bumibilis. Diba? And also, syempre, habang pababa siya, its height also decreases. Okay? And ang mapapansin nyo sa kanyang potential and kinetic energy, okay, at the highest point, the potential is the highest also. While the kinetic, okay, is the highest at the lowest point. And in which mabilis ang, okay, and in which pinakamabilis ang takbo ng ating rider. Okay? So they are all interconnected. So I want you guys to observe clearly the variable as I've said. Okay? Observe the height, okay, at a certain amount of time. Okay? Same with the situation 2. Okay? Shinare ko yung sa situation 1. Kung hindi nyo naiintindihan, you can rewind. Okay? You can rewind this video. Okay? In situation 1, okay, na-explain ko na, but in situation 2, kailangan yung gawin. So, observe clearly the four variables, and then take note sa ating virtual lab, sa inyong virtual lab, ang mga na-observe nyo. Okay, again, the four variables are the height, okay, yung taas niya, okay, and also the speed. Okay, so you can notice the speed kung bumibilis o bumabagal ba, and at which point siya bumibilis o bumabagal. And then, we have here the potential energy, which is the blue one, as you can see sa ating bar graph. Ayan, sa ating bar graph dito sa kaliwa. Okay, yan dyan, potential energy, while the kinetic energy is the green one. Okay, and also as you can see rin sa ating pie graph, okay, that they are simultaneous. Okay, okay, yan, nare-represent nila, okay, ng pie graph at ng bar graph. And as you can see sa ating total energy, as you look in our bar graph, the total energy never changes. So how to compute the total energy? You just compute for the kinetic plus potential plus thermal energy, in which there will be no thermal energy because there is no friction. Again, the ramp is frictionless. Okay, so I want you to, with that simple knowledge, I want you to answer the virtual lab, okay, for our situations 1 and 2. Again, nasabi ko na yung situation 1. Situation 1, I already explained it. And you are going to be the one to explain the situation 2. So, good luck doing that. And as you finish doing it, you can proceed na. Pause mo na yung video na to. But, if you already finish na, o pag natapos nyo, you can continue watching. Okay? So, hindi to mawawala since uploaded naman to sa YouTube. Okay, next, we will go on with the situation 3. So, tawag dito, paalala lang, okay, the situation 3 is not in the frictionless ramp anymore, but it is in the rough ramp. Okay, which means there is a friction. The friction is present, and thus, anong energy ang naproproduce during friction? Okay, yung wala kanina, which is the thermal energy. So, as you can see here, okay, so tingnan nyo muna ang ating bar graph. Okay, bar graph dito. Okay, there is a presence of thermal energy na. Okay, and as time goes by, it is slowly, okay, ayan, umulit. Okay, as time goes by, the thermal energy is slowly increasing. Okay, so I want you to see this one. Okay, ano ba napapansin nyo while the thermal energy is increasing or as time goes by? Okay, kung kanina, the initial height of the skater from first point going down to going up is always the same. Okay, but in this one, as time goes by, mas kaunti o mas pababa ng pababa ang height na naaabot niya. Okay, so as you can see here, hindi niya na maaabot yung kanyang initial position, or yung maaabot niya is mas mababa sa kanyang initial position. Okay, o mapapansin nyo, di ba? Okay, so that is because, okay, the total of kinetic and potential energy ay nababawasan. Okay? The kinetic and potential energy ay nababawasan at napupunta sa thermal energy. And which means, kapag ipag-add nyo silang lahat, there will be a certain total energy din. So, you can infer that the total energy is still not changing. Okay? So, nagkakaroon thermal energy, but that is because of the potential and kinetic energy. So, as the thermal energy increase, the total of kinetic and potential energy also decreases. Okay? Because the total energy must be always constant. Okay? So, it is very helpful sa ating magiging problem solving. Okay? So, we're just building concepts here. Okay? So that you can understand. Okay, so let's move on. Okay, yan lang ang catchphrase or yung catch sa sa situation number 3 natin. Okay, the thermal energy. Okay, so I want you to to observe the height. Okay, ang height na and observe the speed or the velocity. Okay, as well as observe the kinetic and potential energy. Okay, so let's proceed. Okay, so dyan nagtatapos ang ating virtual laboratory. If you are finished na sa ating virtual laboratory, you can proceed to the video. Again, if you are still not finished or gagawin nyo pa lang, just pause the video and replay or resume the video once you finish the virtual laboratory. Okay? So, let's move on. Oops, nangyayari na dito. Okay, so let's move to the lecture part of our lecture video. Okay, so the law of conservation of energy, tataas ko muna ang aking sarili dito. Okay, law of conservation of energy, or this is the lecture proper. So we have, again, I divide it into 3 parts. The total mechanical energy part, okay, the work done by non-conservative force, and additional examples. Okay, so the total mechanical energy, okay, so let's move on with total mechanical energy. So this one ay nakuha ko lang din sa inyong sa inyong mga module. Okay, so let me explain it lang shortly. Dito ako sa walang Okay, so potential energy is stored energy of position. Okay, potential energy comes in many forms, but in this lesson we will only focus on the gravitational potential energy. As you can see, the potential energy is the energy that is stored in an object. Okay, the higher it is, okay, the higher its potential to fall, or the mas mabilis yung pag-fall niya. Okay, thus the more energy. Okay, but if it is already in the ground, there will be no potential energy. Okay, so it is directly proportional to the mass of the system. Syempre, higher the mass, the more energy it will give when it fall. Okay, to the height, syempre kapag mas mataas, it will fall harder. And the gravity of the surrounding. Okay, so the higher the gravity, the higher the pull of gravity, the higher the energy also. Okay, if one of those variables becomes 0, okay, if there's no gravity, or there's no height, or there's no mass, the potential energy will be 0. Okay, oh yeah, that's why its formula is always mass times gravity times height. Okay, so let's explain in view of the simulation. In the simulation, as the skater slide down the skate ramp, making its height decrease, his potential energy also decreases. Again na nga, ngayon ang sinasabi natin, as you can napapansin nyo sa height na sa ating virtual lab, as the height goes lesser, or bumababa yung height, okay, the potential energy also decreases. So they are directly proportional to each other. So as you can see here, okay, sa ating proportionality dito, okay, PE is directly proportional to the height. Okay, next. Punta tayo sa kinetic energy. Okay, kinetic energy is the energy of motion. Okay, because if the potential energy is the energy of position, or stored energy of position, kinetic energy is the energy in motion. Once na gumalaw na siya, okay, maybe because of the external forces or other applied forces, or even the potential energy, okay, the object will now have the kinetic energy. Okay? It's like the kinetic energy, you will feel it kapag nabangga ka ng isang bagay na gumagalaw. Gaano kabilis, gaano kalakas ka nabangga, or gaano kalakas ang impact, the higher the kinetic energy. Okay? It is a simple concept with a simple equation that is simple to derive. Okay? Meron yan, sa ating module, meron diyang derivation of the kinetic energy. Okay? You just have to read it na lang. Okay? Naka-detailed naman yan doon. We will not explain it here. Okay? I want you to paganahin ang inyong mga critical thinking. Okay? Okay, so let's relate it sa ating simulation. Okay? Or the virtual lab. From the virtual lab. In the simulation, as the skater slide down, the skate ramp speeds up. Okay? His kinetic energy increases. Okay? So as the skater slide down again, habang pababa siya ng pababa, okay? The skater, the velocity of the skater also increases. Okay? And thus, its kinetic energy also increase. In contrast, ganun din, kapag pataas na siya, napapansin nyo, bumabagal na siya. It is because tumataas na siya. Okay? And thus, the kinetic energy becomes the potential energy. Okay? Sa situation 1, habang bumababa siya ng bumababa, the potential energy is being converted into kinetic energy, and thus, bumibilis siya. As we can see here, kinetic energy is equal to, the change in kinetic energy is equal to 1/2 of mass times the square of velocity. Velocity squared. Okay? So, in contrast, yun na nga, kapag pataas naman na siya, the kinetic energy that is being induced, okay, ay nako-convert into potential energy. That is why, okay, so that is why the total energy is always constant. With that, we can prove that the kinetic energy that as the kinetic energy increases, okay, the velocity increases, and thus when the kinetic energy, the velocity decreases, the kinetic energy also decrease. So the kinetic energy is directly proportional to the squared of the velocity. Okay? Next, we move on. Okay? We move on sa ating Okay, so this one, I will introduce now the law of conservation of energy. Okay, now let's just discuss why the potential energy decreases as the kinetic energy increase. So medyo intriguing, di ba? Bakit kaya? And why it increases as the kinetic energy increase or decrease, which can be observed in the simulation. Makikita nyo sa ating bar graph and the pie graph doon sa aking pinakita na animation. Okay, the law of conservation of energy implies that energy can neither be created nor destroyed. Okay, so the energy, you cannot create an energy and you cannot destroy energy, although it can be changed from one form. Okay, kung anong klaseng forma siya, is it mechanical, kinetic, potential, chemical energy, okay, into another form of energy. Okay, it's like when you are requiring energy or kailangan mo ng energy, you just have to convert from one form of energy. For example, when you are naiinitan ka, okay, naiinitan ka, kailangan mo ng ng hangin or papaypay sa'yo, o di kaya punta ka sa aircon, di ba? You still have to charge, okay, or isaksak sa outlet ang yung electric fan or yung aircon para, okay, para mahanginan ka. Okay? It's like you turning electrical energy from the power plant din also para magkaroon ng mechanical energy sa electric fan. O para ka lang din nagpapaypay sa kaibigan mo. Okay? Yung kaibigan mo, syempre, nahihirapan siyang syempre, mahirap naman magpaypay. Ikaw, try mong magpaypay. Diba? Nakakapagod. Hindi naman siya nakakapagod sa una, but nakakapagod siya sa kapag matagal na. Okay? So that's the form of energy, the simple application of energy. Okay? You get what you want. Okay? The wind energy, okay? Para mahanginan ka. Okay? But in turn, kailangan niya ng mechanical energy. So mechanical energy from the paypay ng kaibigan mo or the electrical energy in which sinaksak mo yung yung aircon mo, okay? Or yung electric fan mo is turned into the mechanical energy and thus turn into a wind energy. Okay, so if you want to have an energy, you just have to change a certain form of energy into another na kakailanganin mo. Okay, let's proceed. In an isolated system, the sum of all forms of energy therefore remains constant. So kung ang iyong if you are just changing from one form of energy to another, okay, thus the total energy is not changing. Okay, so therefore it will always remain constant. Why? You didn't decrease it. Okay, again, ako-convert lang siya. Okay, when one form of energy decrease, another form of energy increase in the same manner. Okay, so thus the total is always constant. Okay, for example, a falling body has a constant amount of energy, but the form of energy changes from potential to kinetic. As you fall down, okay, pag nasa taas ka, okay, maybe you are not moving but you have high potential of falling. Okay, kapag binitawan ka. Yeah? But as you go down, okay, the potential also decreases. However, okay, as you fall down, okay, the okay, the harder or the habang pababa ka ng pababa, the faster you fall. It is because the potential energy from a certain height is being accumulated into kinetic energy, thus it is being, okay, manifested into a velocity of falling or the rate of falling. Okay, so that is what happens. Okay, and thus the energy total is equal to the summation of energy initial or summation of initial energy, which is also equal to the summation of final energy. Okay, so the total energy is always constant. Before or after, it's not changing. Even when it is in initial state, or in a final state, or in between, it will be always equivalent to the quantity of the energy total or total energy, as we can see sa ating equation dito. Okay, so next, let's move now. Okay, in the first and second part of the virtual lab, we don't take into consideration the work done by non-conservative force since the ramp is frictionless. Okay, again, we don't take into consideration sa situations 1 and 2. Okay, since the ramp is frictionless, thus the potential energy are acting upon the system to do its work. The formula will only be, okay, so since the ramp is frictionless, okay, the total energy or some form of energy will not be converted into a certain form or other forms of energy. It will always be in between potential and kinetic energy. Okay, so we take the equation sa una. Okay, E total is equal to the summation of initial energy, which is also equal to the summation of final energy, where the energy initial or the summation of initial energy is always equal to the potential energy plus initial plus the kinetic energy initial, same as with the final energy summation. Okay, it is also equal to the PE final and the KE final. And thus, okay, switching up, okay, substituting that, we can see from E summation of initial energy to the summation of final energy sa baba. Okay, we can see that the PE, initial PE or initial potential energy plus initial kinetic energy will always be equal to the final potential energy plus the final kinetic energy or the summation of the final energy. Okay, so diyan na-derive ang total mechanical energy or yung law of conservation of energy. Okay? So that is it for examples. Okay, these are the examples. Okay, so pabilisan lang natin. The initial height of the rock of this figure. The figure is 3 meters. Calculate the rock's velocity when it has fallen to 1 meter above the ground. Okay, so we will not be able to solve it due to time constraint. So, I believe magigets nyo naman na yan. Okay, kapag sa mga examples. Okay, but I will just show how they solve it. Okay, I just want you to understand the problem and how we will be solving it so that when you read the module, okay, you will be interested in, okay, to know how to come up with the answer. Okay, so again, the given here are the initial height of the rock, which is 3 meters. Okay? I raised, okay, meron tayo ditong diagram. I raised a rock, or certain people raised a rock in which is 3 meters high. Okay? Calculate the rock's velocity as it falls. Okay? The rock's velocity when is fallen 1 meter above the ground. So, binitawan siya at around 3 meters. Okay? Nag-fall siya na nag-fall. And at a certain level or 1 meter level, ang tanong dito is, gaano na siya kabilis? Again, magkakaroon na siya ng bilis dahil yung mga potential energy niya from 3 meters down to 1 meters has been converted into kinetic energy, which is the same equivalent sa certain velocity or yung bilis ng pagbagsak. Okay? Which is, sabi nga natin, proportional to the square of the velocity. Okay, so approach, we apply the principle of conservation of energy, yung equation kanina, yung unang-unang equation, or yung huling equation, natin, PEI plus KEA sub I equals the PE sub F plus KE sub F. Okay? Okay, we apply the conservation of mechanical energy with only gravity acting upon the rock. We choose the ground as our reference level, or H is equal to 0. Okay, that is our reference level. Okay, so ayan na ang ginawa niya. Okay, so ayan, since VE1, mapapansin nyo guys, sige, solve na lang natin. Okay, since VE1 is equal, ano na natin, summarize. VE1 is equal to 0, or VE1 or same VE1. Okay, kasi nga 1 is the initial. Okay, so bago nagsimula or sa simula pa lang, hindi pa nagfo-fall yung rock, na hinawakan mo pa siya, so ang bilis niya is 0. Therefore, no kinetic energy pa because lahat ay potential energy. Okay, kaya cancel na yung PE1. Okay, and thus, substitute lang, since given naman lahat, yung height 1, which is 3 meters, yung height 2, which is 1 meter, and the gravity is 9.8 meters per second, and the velocity 2 yung hinahanap, or the final velocity. Okay, transpose lang yan, and makukuha nyo na yung sagot. Transpose and then substitute, you will be able to get the final velocity. Okay, next, example 3.2, if the initial height of the ball in the figure is 3 meters as it rolls down. Okay, so muna dito. Okay, as it rolls down a frictionless ramp, calculate the rock's velocity when a slide 1 meter above the ground. So it's also the same lang din. Okay, same lang siya. Okay, but ang difference dito is it is sliding down. So meron ba siyang ang point lang dito is meron ba siyang pagkakaiba when it is sliding down a frictionless ramp or falling down. Okay, so I want you to see it for yourself if there is any difference, kasi the given are always also the same. Okay, so tingnan natin kung yung sagot ay ano nangyari, sorry, nag-lockdown tayo. Tingnan nyo kung yung sagot ba sa example 1 and example 2 ay parehas. Okay, so you will be able to know it. Okay, okay, if you madidiscover nyo yan siya. Okay, if you want to know it. Okay, just look at the examples. Okay, next, the work done by non-conservative force. Okay, this one, ito na yung ating nasa situation number 3. Okay, this one. Okay, so let's move on. Okay, comparing the two problems, we can assume that the vertical length of the ramp, okay, so yung two problems na yun kanina, okay, comparing the two problems, we can assume that the vertical length of the ramp will not affect the mechanical energy and thus the velocity of the sliding system given that there is no presence of friction. Okay, so if you investigate, kindly pause muna, I will reveal na yung kanina. Okay, so now that you know, okay, we can assume, Okay, napansin nyo na parehas lang yung sagot. So we can assume that the vertical length of the ramp will not affect the mechanical energy. Okay, it's all, we are always looking at the ano, at the vertical, o dapat pala horizontal, the horizontal length of the ramp or the vertical length of the ramp will not affect, or yung yung travel, okay, length of travel ng ball will not affect the mechanical energy. We are always looking at the vertical position or the height of the ball or of the system, okay, and thus the velocity of the sliding system given that there is no presence of friction. Okay, however, if we can apply it in our daily lives with a realistic magnitude of air resistance and friction for both falling and sliding objects respectively, which one will hit the ground first? Okay, or will have higher velocity? Okay, of course it will be the falling object. Okay, guys, we are just since we are not we are talking about free fall motion, okay, and the frictionless ramp. Okay? So, meron tayong nineglect doon sa dalawang problem na yon, the falling one and the sliding one with no friction. So, the falling one will the falling object, okay, ay meron siyang air resistance. However, we neglect it. Sa isa naman, meron talaga siyang friction realistically, okay? Halos lahat naman ng ground ay may friction. Okay? But we neglect it then. However, in a realistic matter, okay, we can say that the falling object will fall first with the speed, or fall first, syempre pababa, mag-fall first talaga siya, di ba? However, it will always be faster, okay, when it fall. Kasi there is less air resistance in falling at a certain height. Okay? Sa kapag at a realistic height. Okay? So there's no, unless sa langit talaga siya galing, ba, mas malakas na 'yon. However, kung titingnan nyo lang, kung nag-slide siya compare sa nahulog, it will always be mas mabilis ang mahulog. Kasi nga there is little or less air resistance than the friction. Okay? Ngayon, of course, it will be the falling object since the frictional ramp takes more energy from the system in a realistic situation. Yun yung sinabi ko. Friction influences the work done by non-conservative force. Ito, ibig sabihin ng work done by non-conservative force, these are, you cannot conserve it. Okay? Or, pag once na kinuha niya na ito, okay, it's harder to transfer it again into mechanical energy. Okay, it will dissipate into the environment, okay, in which it will be the energy will also mag-dissipate na siya into the surroundings. Ibig sabihin, mawawala na siya sa system or sa isolated system. Okay, gets nyo ba? Kaya ang total energy, okay, ang mga nawala doon, that the potential kinetic energy is mababawasan talaga. Okay? So, without further ado, let's move on. Okay, next. Mabilis lang naman to. Work done by non-conservative force. In the last part of the virtual lab, we take into consideration the work done by non-conservative force, the thermal energy since there is friction in the ramp. Okay? So, last part, we take in consideration na yung friction. As we can observe, there is a change in total mechanical energy as time goes by. The value of change in the total mechanical energy goes into the work done by non-conservative force in the system. So total energy is the same. However, the total mechanical energy, which is the potential kinetic energy, decreases dahil nata-transfer yun or na-convert yun into the thermal energy. Okay? So, yun yung sinasabi ko kanina. Kaya nababawasan yung total ng potential kinetic energy, which is the total mechanical energy. It is because yung friction is, yung iba doon ay na-convert na into thermal energy, which dissipates into the surroundings. Okay? Next one. Okay? So, with this one, as you can see, okay, convert ulit tayo. Okay, the work done by non-conservative force, or W sub NC, is equal to the change in potential energy plus the change in kinetic energy. Siyempre, pag nabawasan yung potential and kinetic energy, okay, that will be equivalent to the one na yung work na done by the non-conservative force. Okay? Where the change in the PE is equal to the final minus initial kinetic potential energy, same as with the kinetic energy, which is also equal, the change in kinetic energy, which is equal to the final minus initial kinetic energy. And thus, substituting this, we can see here, PEF W sub NC is equal to the potential energy final minus potential energy initial plus the KE final minus KE initial. Okay? Transpose, or rearranging the equation, we can finally see, okay, we can now know that the PEI plus KE sub I plus W sub NC is equal to the PE sub F plus KE sub F. So, in our previous formula, wala pa yung WNC. So, nilagay lang natin siya sa part na may mga initial. Okay? So, napakadaling tandaan. Okay, next. Yan lang ang kanyang formula. Okay, so I hope you're taking notes. Okay, let's apply it sa certain examples. Okay, example 3.3. Okay? So, I will just explain the problem and sabihin kung ano yung paano siya sinolve. Okay, I just want you to solve it for yourself din. Okay, I just want you to study the module din syempre. Okay? If the initial height of the 3 kg steel ball in the figure is 3 meters, okay, 3 meters siya dito sa taas, as it rolls down the 45 degrees ramp. Okay, the ramp is inclined 45 degrees. Calculate the rock's velocity when it has slide to 1 meter above the ground. Okay, the coefficient of kinetic friction is 0.31. Again, ang ating problem dito is almost the same lang sa example 3.1 and 3.2. Ay, sa 3.2 pala, sorry. No, almost the same lang din yung mga materials or mga variables. 3 meters yung initial height, final height 1 meter again, and the mass is 3 kilograms ulit. Okay? The purpose of this one is for you to see how a certain changes or certain situation can change or not change the final output or the final values na hinahanap natin, in which titingnan natin dito is the rock's final velocity or the velocity at 1 meter height. Okay, approach, we apply the principle of conservation of mechanical energy considering the work done by non-conservative force given the presence of the friction. Yun na yung formula kanina na tinake note nyo. Diba? We choose the ground as our reference level again. H is equal to 0. And the reference level mo. First, we will solve the work done by non-conservative force. Okay? So, dahil ang ating formula ay meron ng W sub NC, you will also solve the work done by non-conservative force. Very easy. And then, same na lang din yung gagawin nyo dun. Okay? In finding the D or the distance, you will use the trigonometric functions or trigonometric identities. Okay? So, alam nyo na yan sa inyong calculus. We already, yan? And also trigonometry nung inyong junior high school. So, you just have to balikan ang yan. Okay, that's why we use the trigonometric functions. Okay, the SOHCAHTOA. Okay, kasi hanapin natin yung D. And then next we will find the friction. So finding F, ayan sa ating dynamics na part. Okay, pwede niyo na yung balikan. Okay, thus the W sub NC is equal to friction times lobat na. Wait lang guys. Okay, the friction times the distance, which is equal to the negative 6.5 newtons times the 2.8 meters na nasolve natin, and thus the work done by non-conservative force is negative 18 joules. Wait lang saksak ko lang. Sorry. Okay, negative 18 joules. At the moment of release, the ball's position is 3 meters and the rest is 0 kasi yung velocity niya, syempre 0 at rest, kaya na kanina. Okay, we want to find the final velocity when the ball is at position 1 meter. So, yun ang sinabi natin kanina. Diba? Okay, so this one, at the moment of release, the ball's position. So, anong ginawa natin dito? Okay, we just, same lang siya sa ating example 3.2, but tinanap lang natin yung work done by non-conservative force. Sinubstitute natin yung negative 18 joules dito. Thus, you will be able to know that yung una kasi is 6.3. Ngayon, the velocity becomes 5.2 meters. So, that is the impact of the friction. Okay, the friction, sorry. The presence of the friction or the thermal energy pag na-convert na. So, bumagal din ang bola dahil ang kinetic and potential, ang ibang potential energy ay na-convert into thermal energy due to friction. Okay? So, that is our example number 3. Okay, example number 4, you already know this. It's also the same. Okay, you will just find the tawag dito. Ayan, the velocity 2. Okay, you just have to study it na lang. Okay, yung A, ang hinanap lang is the V2. Okay, syempre yung sa A is walang presence ng friction. Diba? Ng non-conservative force. Okay, whereas sa B, meron ng non-conservative force. Okay? So, let's move on. Okay, let's move on sa additional examples. Okay, example 3.5. So, kayo na yung gagawa nito, guys. And I will reveal rin yung answer keys. Makita nyo rin sa answer key dyan. So, 3.5, select a letter for each. Okay, A, B, C, D. Alin yung nag-stop. Okay, yan yung bar graph natin kanina sa ating virtual lab. Okay, kung gusto nyong malaman yung sagot, you can revisit the virtual lab. Alin dito sa ABCD ang kanyang energy summary kung siya ay naka-stop, okay, or kung siya ay at its slowest velocity, and which one naman yung fastest. Okay, so pili lang kayo sa ABCD. Next, we have the example 3.6. We have a novice skier starting from rest, slides down a frictionless 35 degrees incline. Okay, so nag-start siya from at rest, okay, and then it slides down at incline of 35 degrees whose vertical height is 1.85 meters. So medyo mataas yung kanyang height, initial height. How fast is she going when she reaches the bottom? So as it reach the bottom, gaano kabilis yung siya nagta-travel? Okay, again, reminder lang, this is a frictionless ramp. Okay, sorry. Full screen tayo. Okay, next, let's move on with our example 3.7. Okay, so the same lang rin yan sa ating mga example na kanina. Okay, sa example 3.4. So you just have to see the example 3.4 and then recreate lang din siya or i-apply nyo siya sa example 3.7 syempre. Okay, and also we have 3.8 is also almost the same. Okay, meron lang kayong mga dapat na i-apply. Okay, na ibang mga variables sa ating other lessons kung meron man. Okay, because they are all connected. Okay, lastly, let's go to the assessment. Okay, so we have the components of our summative assessment. So if you are ready to answer your summative assessment, just listen to our lecture here. Okay, so the components are multiple choice, problem solving, and lastly the experimental output. So hindi ko na yan sasabihin sa inyo. Okay, So I will just explain each and every one na lang. Okay? Again, multiple choice. That's just a concept lang. Okay? And then concept lang yan, ABCD. Mainly sa inyong wala naman atang solving diyan. Mainly galing sa inyong virtual lab. Okay? Concept lang yan. Okay? So you just have to review or familiarize yung mga concepts, especially when using the virtual lab, which is also part of our learning outcomes. Okay, next, let's go with the problem solving. Okay, so ang may bibigay ko lang sa inyo problem solving is ang rubrics, okay, to explain. So, each problem solving, I believe I have, I don't know, 3. Okay, 3 problem solving dyan sa inyong module. So you have 5 points. If you will get 5 points if the solution is correct and the answer is in all incorrect units. Okay, 4 points naman if the answer is correct but wrong units or missing ang unit. 3 points naman if the solution is correct but the final answer is wrong. But maybe nagmali lang kayo sa dulo. And last one is you will get 1 point if the solution and the final answers are wrong. Okay, so next, that is our problem solving rubrics. Each will have 1 point, 5 points. Okay, then we'll go to the part 3 of summative assessment, the experimental outputs in which I will explain. Okay, model an inclined ramp. Okay, you will model an inclined ramp and 3 various sliding objects as your 3 trials. Okay, so we'll have 3 trials but iba't ibang klase ng object that is sliding. Okay, syempre mas better yung mga object na gumugulong or nag-slide mismo, yung makakarating sa baba. Okay, also prepare some measuring instruments like ruler. Okay, you will design it, guys, ha. Okay, yung ruler, okay, pang measure ng distance. GPS speedometer app, okay, meron yun sa mga app sa phone, ganun yung bilis niya. Okay, ilagay nyo lang siya doon, or tawag dito, paano nga ba yun, di ba? Okay, si sensor lang yan nila, or maybe i-attach nyo yung phone sa inyong object. Okay, and then design an experiment to determine the thermal energy dissipated from the system. Again, you will be able to get the thermal energy dissipated from the system by using or transposing yung mga diniscuss natin na problems. Okay, you can get the idea sa ating mga problems sa pag-solve. Okay, however, sa experimental design nyo, okay, syempre, kailangan nyo lang i-design nyo yun kung paano nyo makukuha yung thermal energy na dissipate from the system. Okay, use the equation, ito yung sinabi ko, use the equation for the conservation of energy to get the thermal energy. Okay, ayan yun. The purpose of this are to prove, ito na yung purpose, that there is thermal energy dissipated from the system. Okay, ipo-prove nyo na meron nga ba talaga, and to show how far or how close each trial to each other based on the type of material. Okay, so alamin nyo lang kung depende ba sa material o may impact ba yung klase ng material sa sa dissipated energy. Okay, you will know. In which part rin siya ng ating learning outcomes na you will sabi doon sa ating learning outcome number 2 ba yon? Okay, you will experience it first hand. Okay, so these are the components na kailangan makita ko doon. Okay, your experiment must contain the following. So a total of 35 points. The introduction must be 5 points. The objectives are 5 points. The materials, papakita nyo doon, syempre 5 points. Also the procedure ng design nyo, 5 points. The data table, yung presentation of data, okay, the tables are 5 points also. And the sample computations, 5 points, with a conclusion that is 5 points. Okay, so next, let's move on with the answer key. These are the answer key sa ating mga problems, sample problems. Pinakita ko sa inyo kanina. Okay, the stop is letter B because there's no kinetic energy. Slowest is letter A with the least kinetic energy, and D is the fastest with the maximum kinetic energy. So bad. Okay, again, and then example 3.6. is 16.2 meters per second. Example 3.7 is 33 meters. And then the example 3.8, the thermal energy is 147 kilojoules and the friction is 370 newtons. Okay? And with that, this is my sources or the references. Okay, I get from books, okay, and modules na aking master's teacher sa master's. Okay? Also, I use some journals and syempre FET Colorado, yung ating simulator. Okay? And even sa mga internet, kumuha din ako. Okay? And also, this presentation is provided to you by the Prezi. Okay? As I'm always using. Okay. So, yun lang guys. Thank you very much. I hope you get. Okay? Na-gets nyo ang may natutunan kayo. And I wish you good luck sa pag-answer sa ating mga modules. Okay? So, thank you very much guys and have a great day.